Hi, boys and girls. I want you to consider my number cube here for a minute. Take a look at it. I'm going to do a little bit of geometry review with you and ask you this question. How many faces does my number cube have? Come on. Thomas, what do you think? That's correct. It has 6 faces. It's a cube, so it has 6 faces. 1, 2, 3, 4, 5, and 6. So we have 6 faces on this number cube. What else can you tell me about the faces of this cube, Molly? They have numbers on them, correct, but just the shape of the face, of each face. Yes, they're squares. Thank you, Molly. They're squares. And not only are they squares, but what's that word we use when we're talking about the same size and shape? Excellent, Zoe. You got it. Congruent. So each face of this cube is congruent. Now, let me ask you another question. If I were to roll this die or throw it, what are the possible outcomes? So when we're looking at an event or something that could happen, we look at the possible outcomes that could happen. So what are the outcomes of rolling this die? We could roll a 1, or we could roll a 2, or we could roll a 3, or a 4, or we could roll a 5, and finally we could roll a 6. Now, let me throw this up on my computer screen and we can talk about this a little further. Screen now. If I were to roll my number cube, there would be some possible outcomes of that event. And my possible outcomes are, I could roll a 1, I could roll a 2, I could roll a 3, a 4, a 5, or a 6. That's it. Those are all my possible outcomes. Now here's where I noticed that we were having a little bit of trouble with our math yesterday with the spinner. A spinner, a number cube, it doesn't really matter which one we're talking about. The ideas and the concepts stay the same. So I want to walk you through a number cube today because as we move forward in our lessons, we will be using number cubes and we will be using spinners and other means to study probability. So here's my number cube. Here are my outcomes. Let's take a look at what is an impossible outcome to have here. If I were to roll the die, here's all the possible outcomes. What would be an impossible outcome? Absolutely no chance of happening. What do you think? Oh, that's a good answer, Travis. I like that. Okay, I'm thinking the same thing you're thinking. Rolling a 7. Rolling a 7 would be impossible. Rolling a 12 would be impossible, and so on. It's not one of these outcomes. So it's not possible to happen. It is impossible. I think we're pretty good with impossible. Let's take a closer look at certain. What is certain to happen? Well, if I roll the die, it's certain that I am going to get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. I'll get one of those for sure. Absolutely, it's going to happen. One of those numbers will come up. So when I'm talking about being certain, positive that it's going to happen, that's the only thing I can really say. Because even if I took away one of those and I said a 1, a 2, a 3, a 4, or a 5, could you be certain that that's going to happen or that would be an outcome? No, because there's always that little chance that it could be a 6. All right, moving on. Let's take a look at unlikely. Now, here's where some of the confusion set in yesterday. It is unlikely that I would roll a 1. So if I was going to roll my die and I said, okay, here we're playing a game, I need a 1, you would say, Mr. McGeen, come on. It's unlikely you're going to get a 1. It's not impossible, I might get one, but it's unlikely. Because when I compare it to all the possible outcomes, there's only one chance of me getting a 1. And there's all these other numbers that could come up. So I would say that rolling a 1 is unlikely. Rolling a 2 is unlikely. Or rolling a 3 or a 4 or a 5 or a 6 by themselves, they are all unlikely events. They're probably not going to happen. Now, one of them will, but that just shows that sometimes unlikely events actually happen. Okay? Let's take a look at equally likely. It is equally likely that I could roll a 1 or a 2. So notice what's happening here. We said rolling a 1's unlikely, and now you're going, Mr. McGee, you're driving me crazy. What's happening? I can almost hear Peyton saying this to me. What are you talking about, Mr. McGee? You just said rolling a 1 is unlikely, and now you're saying it's equally likely. But look what's happening here, Peyton. I am comparing rolling a 1 to rolling a 2. So really, I'm only looking at those two possible outcomes of me rolling a 1 or rolling a 2. So because both of those have the same chance of happening, we would say that the chances of rolling a 1 or a 2 are equally likely to happen. Or rolling a 4 compared to rolling a 2. Well, those chances are equal. There's only one of each of those numbers on the die, and they have an equal chance of happening. So yesterday when you're doing your spinners and you're looking at them, sometimes we were getting a little confused with that language because we weren't looking at the possible outcomes. The likelihood or the possibility of me rolling a 5 is exactly the same as me rolling a 2. So we would be saying they were equal. And there's lots of other equally likely outcomes as well. Consider this. How about rolling an even number? Well, what's the possibilities here? I could roll an even number, a 2, a 4, or a 6, or I could roll an odd number, a 3, a 5, or I put a 7 here. Boop, boop, in, change, 3, 5, or 1. There we go. 3, 5, or 1. So these two really are my only outcomes. I could have an even or I could have an odd. And because each of those have 3 outcomes, well, they're perfectly equally likely to show up, right? So here rolling a 1 is unlikely because we're looking at it compared to all the other outcomes. Here rolling a 1 is equally likely when we're comparing it to one other of the outcomes. Or here, a 1 is equally likely to happen because it's in this group of odd numbers, and we're really looking at rolling an even number or rolling an odd number. Okay? So a little bit confusing, but I really want us to wrap our minds around this language because next week we're going to start putting numbers to the chances of happening. Those are called probabilities. And finally, let's take one quick look down here at likely. It is likely that I would roll a 6, a 4, a 2, or a 1. Because look what I've gone and done. I've given myself 4 chances of rolling a number and only 2 chances that I would not get the number I was looking for. So because there's a better chance of rolling a 6, a 4, a 2, or a 1 than missing and rolling a 3 or a 5, then we would say that it's likely that I will roll one of these numbers for sure. Okay? So go over that a little bit. Make sure you're talking to your moms or dads and make sure you understand the differences between not just certain and impossible, but everything in between, those possibilities where we're talking about unlikely, equally likely, and likely. Here I am at toytheater.com, and I thought this was kind of neat. Today's activity or assignment, you are going to need to roll a die or a number cube. I found this is like a virtual number cube rolling experience. It's pretty fun. And we can change the look of our die. We can change how many die we're using. But for this experiment, we're going to be using one die. I have it here. And by simply clicking on the throw button, my die rolls. And there I rolled a 1. Now, let's say I'm going to try and roll a 5. Come on, 5. I want a 5. We just talked about the likelihood of that happening. Is rolling a 5 impossible? Certain? Likely? Or unlikely? What do you think? It is unlikely I'm going to roll a 5, but I'm going to try anyways and see what happens. Here we go. I'm going to click on roll or throw, and I rolled a 4. It's not the 5 I was looking for, but that's okay. If you want, you can use this dice rolling virtual game, or you can simply use a real die that you have around your house to complete our activity today. So check out toytheater.com. There's some really cool interactive things you can do, and one of them is this die rolling tool. So here's your assignment for today. It's a really fun experiment. You get to play around with rolling some die. I want you to have fun with math. As always, math is awesome. It's fun. Enjoy it. A copy of this is on our math post. Enjoy your long weekend, and I will see you all back again on Tuesday.